Hello guys, in this video let us discuss TCP versus TCP IP versus IP address versus port. So guys, first thing, if you know these concepts, simply skip this video. Now you may have a question that why we are discussing this TCP, that is protocol versus port. So it's because NSG, that is network security group, it works with protocol or port only. So again, NSG, that means network security group. These are security rules and they decide who can enter our subnet and who cannot. Now guys, assume we have two systems or two machines. So let's say this is machine A and let's say this is second machine or second system. Let's say this is B and we want to send message or we want to send data from A to B. So obviously to send message from A to B there has to be some protocol or some rules, right? So these are defined by this TCP IP. So in simple word, TCP IP, it is a terminology and you can consider it as a book of rules. So using TCP IP we can send message from this system A to system B. Now this TCP IP, it has two parts, that is this IP. See guys, when we transfer data from A to B, obviously we should know the IP address, right? So let's say IP address of A is 1.2.3.4 and IP address of B is let's say 5.6.7.8. Now this IP, that is the part of TCP IP terminology, it decides or it finds the IP addresses. Okay, so simple. And then this TCP IP protocol, it has something called TCP. See guys, now we know the IP address of A and IP address of B, but then there has to be some mechanism through which we can send data from A to B, right? So there has to be some mechanism or some protocol, and that is TCP. So TCP, it is a protocol which ensures that message gets completely delivered from A to B. So basically this TCP, when it transfers the message, it divides that message into something called packets. So when message is sent from A to B, it is divided in packets and then these packets, when these are received in B, they are rearranged. So TCP ensures that the complete message gets delivered and also the packets, they are received by this receiver in the correct sequence. So again guys, let's keep it simple and let's not go in much details, but then this is overall what TCP IP is. Okay. And now let's try to understand what this port is and why we have this port. Okay, so let's imagine this is a postman and he wants to deliver wedding cards, and let's imagine this is the building. So again this is building. Now guys, when this postman he wants to deliver wedding cards, he cannot directly deliver it to building, right? So he will deliver it to a particular flat within this building. So let's say this is flat number 101. Let's say this is flat number 102. Let's say this is flat number 402. Let's say this is flat number 602. So let's say this postman, he wants to deliver wedding cards to these 4 flats. So obviously he cannot deliver it to building directly, but then he can deliver it to individual flats. So in layman terms, consider this building as your IP address and this flat number or apartment number as port. So you can see within a building, this postman can deliver this wedding card to multiple flats or multiple apartments, right? And let's say this flat 101 and 402, if these two flats are close, that's okay, he can still deliver the wedding card to this flat number 102 and flat number 602 as well. So guys, this is really a very simple explanation in layman terms. Okay, so I just want you to understand the concept. So similarly, if you see again, we have this system A and system B. So obviously for A and B we have this IP address, and again IP address is like a building, but from A to B we can deliver the message over different ports. So for example, let's say I can deliver this message from A to B over HTTP. So let's say this is HTTP port of B. So I can deliver this message over HTTP. So HTTP, that means port number 80. Similarly, from A to B, I can deliver message over RDP. So let's say This is RDP port. Okay, so port number is 3389. So similarly, I can deliver message over HTTPS or SSH like that. So you can see, if we have closed the port for HTTP, that is port number 80, but we can still deliver message from A to B over RDP. Okay, so if you want to ensure that message does not get delivered from A to B at all, that means we need to close all the ports. Okay, now I guess you can visualize or you can imagine that when you want to enable such message delivery over the network, okay, between two systems, we should ensure that only relevant ports are open and all other ports, they should be closed. So for example, let's say this is our VM and we have hosted a web app over here, and we want to make so as of now we can connect to this VM using RDP, that is remote desktop, and we can connect to this VM, that is application hosted in this VM, using HTTP, because we have web app over here, right? So we have two ways to connect. So ideally, if this VM is intended to host only web app, then ideally we should close this RDP port from public access, that is from access from public internet, and only access from HTTP should be allowed. In fact, even that is also not good approach. That is when we have hosted web app in this VM, ideally in front of this web app we should use something called application gateway. But I just want to keep it simple that if this VM it has web app hosted as well, then ideally access to RDP should be closed. That means, in simple words, only access to required ports that should be open. And now, to restrict such access to VM or resources within a subnet, we can use NSG, and these NSG, they work with these protocols. So for example, protocol something like TCP or HTTP and ports.